Assalamualaikum again and good day everyone. I hope you still bear with me to finish up this first chapter. Okay, so let's continue with the specific gravity. Okay, so what actually a specific gravity and what the importance knowing the specific gravity? Okay, so usually we want to know the soil specific gravity because we want to know whether the soil is dense or not compared to the density of water so it comes the equation specific gravity is noted as G sub S and the density of the solids of the soil or ms divided by volume of solid, mass of solid divided by volume of solid, or if it comes in the weight term, so weight of solids divided by the volume of solids in the gamma of S, gamma solid. So either we want to have a specific gravity in gamma or in the rho, the density or the unit weight. Okay, so it is a comparison for the solids to the water. So we can know, knowing the soil either it dense more than water or not. Okay, so the specific gravity usually varies between 2.6 to 2.8 and it can be tested in the laboratory. And you have to note that the rho of water, density of water is 1000 kilogram per meter cube, and for the unit weight of water, it is 9.81 kilonewton per meter cube, or sometimes easily denoted as 10 kilonewton per meter cube. And usually we do the specific gravity test because it is easy to define. And from the specific gravity, a lot of relationship, a lot of equation can be easily used so that we can reduce the numbers of tests in the field. We don't need to do all the tests. We just knowing the specific gravity and we can have a lot of data, a lot of data which is later maybe important for our construction projects. Okay, knowing the GS is one of the crucial. So next is the relationship between unit weight, moisture content and specific gravity, or either relationship between the density, moisture content and also the specific gravity. So in this slide, I'm choosing to define the relationship between unit weight only. But in your own terms, in your own free time, you can try to derive the relationship between density, moisture content, and the specific gravity. Okay, let's start with this diagram. So what we want to do is we want to produce a relationship. So we sometimes easy to assume the volume of solid is equal to 1. Means maybe volume of solid is equal to 1 meter cube or 1 centimeter cube, 1 millimeter cube, or any. It's up to you to do the measurement terms. But it is taken as 1. So whenever when you do the real calculation, you just need to times the real volume of solid. Okay, so when we use the assumption of Vs equal to 1, so what advantages that we can achieve? So we can produce a lot of equation, of course, later on we show you. Okay, but what happen is when we have Vs equal to 1, so automatically, if you still remember, Vv and Vs is void ratio, right? Okay, if I can write down in here, we already learned Vv over Vs and previously and Vv over V total, right? They're siblings. This sibling. So when Vs is equal to 1. So that's why VV is equal to E here. Right? So what about V? What about V? V total. So of course, V total is E plus 1. E plus 1. Okay, about VW, volume of water, let's KIV first, keep in view. Later on, we can easily derive also. But next, I would like to assume, I would like to derive about the weight of water and also weight of solids with the GS and also the moisture. So when the volume of solid soil is 1, or we have Vs equal to 1, therefore we know that specific gravity is the ratio of unit weight of solid to the unit weight of water, and unit weight of solid is actually weight of solid ratio to the volume of solids. So we can get, when this is 1, so we can get Vs equal ratio to the gamma water. So if we rearrange this one, so we get Vs equal to Gs times gamma water. And we know that in moisture content is actually Vw divided by Vs. So we goes here times the moisture content, so we get Vw equal to the moisture content, specific gravity, and also unit weight of water. So we get two, this one and another one. So we can get this one. Okay, and also this one. So you can try by yourself how to get the volume of water. So I just leave note here. Volume of water is moisture content times the specific gravity. Okay, so next, there's a lot of derivation we can still produce. So we know that gamma bulk, okay, gamma bulk, so gamma is consists of weight of solids to the weight of and plus the weight of water. So we know weight of solid is Gs times the gamma water. So moisture content plus Gs gamma water is the weight of water, plus volume total is 1 plus E. So easily we can produce new relationship of gamma bulk. 1 plus moisture content times the specific gravity times the unit weight of water, 10 kN per meter cube, divided by 1 plus E. So this is another equation. For gamma dry, so gamma dry is Gs times unit weight of water divided by 1 plus what ratio. And note that volume of water is weight of water divided by unit gamma of water. So we can get WGS, and we know that degree of saturation is volume of water. So volume of water is equal to WGS divided by E. And from the previous equation, S WGS divided by E, so E goes right here, so we can get new relationship also, SE WGS. This one usually I told my previous student to memorize. It is very easy one but very useful one. Okay, and so when we have a fully saturated condition, so when S equal to 1, what happened to the equation? When S is 1, so we can have E equal to WGS. So this is another term of void ratio. Okay? Another term of void ratio with the fully saturated condition only. When the fully saturated condition only. Okay, next. So from here, okay, this is another way to define the void ratio also. But ultimately, That's why I didn't show you yet the gamma saturated equation, because we have to go through all the process first, then we can get now the equation of gamma saturated. So gamma saturated is when the soil is fully saturated the voids. So we can have um, because we know that W is actually WGS gamma water, right? So WGS here is similar to here. So that's why we denote E in these questions. So GS gamma W plus E gamma W divided 1 plus E. So we can factorize the GS plus E times the gamma W outside, and that's why we can have the final relationship of the gamma saturated. So now we already knew the gamma bulk in the new terms, gamma dry, and also the gamma saturated. Okay, after this there's a lot of example. So you can try it, example 2, example 3 with the answers. Okay, and a few more things to cover is air content and also the relative density. So I cover first the relative density. So it is very simple one actually, and you will come across this equation again in the soil compaction chapter. So this is a simple calculation to define the density relatively when we do the compaction. So E max after we do the compaction, initial E max also minus the E minimum. Alright, and go back to the air content. So for the weight, of course, we cannot weight the air, but for the volume of air, from the volume of air, we can know how much air in the soil. So what we need to calculate is we know the volume of voids, so minus the volume of solids, so we can have the volume of air. And we know that when we assume Vs equal to 1, so the Vv become E, the Vs become Se, so factorize the E, we can have Va equal E times the 1 minus S degree of saturation. So the air content is A sub V equal to EVS ratio to the 1 plus E, because the air content is the VA ratio to the V total. So I missed the equation here. So air content equation is V sub A ratio to the V total. So V total is 1 plus E, VA is E times 1 minus the degree of saturation. Alternatively, the air content can be expressed in different manner, like this one also can, this one, and this one. And sometimes the others researcher or others author use N sub A to represent the A sub V. A sub V. Okay, so I think that's all. You can have example 4 and 5 also that calculate the air voids. But later, inshallah, we do exercise and some activity regarding example 2, 3, and some previous tests or final exam questions. So I think that's all for the chapter 1. So Alhamdulillah, we finished. Okay, so see you in the class and in the next chapter. Assalamualaikum warahmatullahi wabarakatuh, and good day everyone. Bye.